Okay, so neural correlates are our last one to cover. If you look at the bits now in green, we've covered genetics, we've looked at dopamine hypothesis, and it's just this final bit of neural correlates we need to look at. Then we'll move on and look at drug therapy and how it's been used to help people be treated for schizophrenia. So neural correlates to schizophrenia. The first thing we need is our overall definition here. So this is where we are taking measurements of the structure and function of the brain, and that it's correlating with an experience. And the experience that we're specifically going to focus in on here, of course, is schizophrenia, and the fact that we see differing activity levels and functioning of structures of the brain of people with schizophrenia compared to people that don't experience schizophrenia. Now, as we go through, we'll be looking at the neural correlates for both positive and negative symptoms. And for you guys, some of these might ring a bell from when we've done our cognitive explanations, because the regions we're going to refer to as neural correlates are those same regions we suggested were responsible for those dysfunctional thinking processes. So this isn't the first time that we have looked at that, and it does mean that we can kind of lean upon your experiences of those different cognitive explanations that we've done so far. So I'll just give you a few moments to make sure you've got that definition down. Make sure you highlight or underline any key words within your definition, and then we'll move and progress on to those positive and negative symptom neural correlates. Okay, so let's start off by looking at negative symptoms and the neural correlates that have been identified for our negative symptom. The negative symptom we're going to focus on initially is avolition. So things that might be responsible for individuals experiencing that absence of motivation and drive. Now, when we talk about motivation would involve the anticipation of a reward. A lot of our behaviour is dictated by the fact that we can see there's a benefit behind doing something, and therefore we carry out that action in order to fulfill and receive that benefit. Now, the region of the brain that's been linked with anticipation is the ventral striatum. Okay, so the ventral striatum on both regions of the brain are suggested to process that information and make us understand the fact that there could be a positive outcome from performing a certain action. Okay, so it's not about reward here. It's about the process of the anticipation of reward and the recognition that certain actions will have positive consequences. What we're therefore going to suggest here is that it's actually an abnormality within the ventral striatum that creates a problem with individuals with schizophrenia. If these regions of the brain aren't working in the way that they should do normally, then individuals wouldn't be anticipating the reward from behaviour, and therefore they never perform those actions and behaviours. So if you're sat there and you don't think there's any benefit in moving, you can't see what positive that would derive for you as an individual, then you're not going to move and you're just going to stay there for probably quite a long period of time. And this is exactly the trait that we would see with individuals with this negative symptom of schizophrenia. The research of Ducal here is quite useful. Ducal observed that there was a negative correlation between the severity of symptoms and the ventral striatum. So that goes beyond just saying that there's less activity levels between individuals with schizophrenia and individuals who don't. This is saying that the more severe the symptoms got, then the less active the ventral striatum was. Okay, so have a little, read through if you've managed to finish. I'll give you another 1 minute to go through that. Make sure you highlight or underline Ducal here. Ducal's going to be one of our evaluating and supporting studies that we use for this theory. So it's just good as we're going through to keep a note of where our evidence will come from. Okay, so as you're just finishing your notes, just be clear on what the key points are here. The fact that we're looking at a region of the brain that's suggested to be involved in anticipation. I'd expect you, if you're giving a nice clear explanation of this theory, to be able to recall the ventral striatum as the name of that region, and to be able to make that link that the fact that this level of activity in the ventral striatum is lower than normal, which causes an absence of anticipation, which causes that knock-on effect of not having that drive to do usual activities. Last few moments with this. Okay, so let's now have a look at a positive symptom, and the research we're going to draw upon here is one that looks at auditory hallucinations. Okay, don't worry too much that we're not going to cover all the symptoms. As I say, you've got a number of different biological explanations, and you wouldn't be asked to write a 16-mark essay just about one of them. You would be given either a shorter question. I'd suggest an 8-mark question would be a pretty maximum number of marks you'd get in a question about neural correlates. So we just need to know enough to be able to give us that clear overview, and being able to give one example of positive symptom neural correlates and one of negative symptoms is enough. So in terms of our neural correlates of positive symptoms, and again, just to buckle in for the terminology being used here. So the researcher here is Allen et al. Allen et al. Gave a group of people that experienced hallucinations to identify what was either pre-recorded speech, identify pre-recorded speech as being either their own or others compared to a control group. So they were trying to basically identify whether this pre-recorded speech was something they had produced or not. Now, what we identify here is that within the superior temporal and anterior cingulate gyrus, that we see lower activation levels. Now think about what's going on within those temporal lobes. That's where we're going to process that auditory information. That's where we're going to find our Broca's region located. And therefore, a lot of our processes in understanding speech are going to come from this region of the brain. So the fact that we see lower activation levels in this region is actually logical in terms of this being a reason why individuals feel like they are unable to detect what is their own inner voice and the voices of others. So again, a couple of minutes just to work through it. Research your name's important because that's going to come back into our evaluation. Understanding what the symptom is that's being associated with the neural area is important, and being able to recall the name of the neural area, in this case the superior temporal and anterior cingulate gyrus, is just that knowledge that will give you high marks here. If you are struggling with neural correlates, it is of course possible to explain these without those terms, but you're going to end up with a less detailed, specific answer, which will achieve less highly in banded questions, or will miss out on marks if it's a kind of checkpoint type mark scheme. Okay, 1 more minute with your note taking here. Right, so in terms of theory, you know, the overall definition and being able to give that overview of neural correlates and then being able to work through a couple of examples of neural correlates is enough here. It's a complex area of the spec. I think it's important that we don't make it any more wieldy than necessary. When it comes to evaluating this particular theory, what I'd suggest that you use is Jekyll and Allen. So use those and present those as evidence. If the question's asking you to describe and evaluate, present them as evidence anyway, because you'll get knowledge for what those particular researchers have shown about neural correlates, and you'll get knowledge for the fact you understand about neural correlates and can give an example as well. Obviously, you might want a little bit more to go on, and what I suggest you use for that is, again, that correlation causation problem, which comes back to really cause and effect. What we're suggesting here is that we are correlating neural activity levels with symptoms of schizophrenia. But what we can't show through correlations is whether it's in fact those regions of the brain that are causing schizophrenic symptoms, or indeed whether schizophrenia as a condition is influencing those structures of the brain and having the resultant effect of them behaving differently to as they would normally. So there's a lot of, you know, opposing theories here that are suggesting that it's actually the schizophrenic symptoms that are having an impact upon those regions of the brain rather than the regions of the brain causing schizophrenia. So it's a very similar question to what we were asking ourselves about the dopamine hypothesis. You know, is it schizophrenia causing dopamine levels to change, or is it dopamine levels causing schizophrenic symptoms? Here, is it the structures of the brain that are causing schizophrenic symptoms, or does having schizophrenia cause your brain to change the way that it's processing information and cause these structures to perform differently to an individual that wouldn't have schizophrenia?